room temperature, 22 or 72. And then body temp, 37, 98.6, which you guys know that one. Then you have water freezing at 0 or 32, and then boils at 100 degrees C or 212 degrees Fahrenheit. And how they got, let me just explain to you how they got the conversion between Celsius and Fahrenheit. Don't worry about Kelvin. There's 3 temperature scales. There's Kelvin, which we'll get to that, and Celsius and Fahrenheit. So let's just zoom in on these two. Now, you notice that if you line up the freezing points, that Celsius starts at 0, and you notice Fahrenheit starts at 32. Then you notice up to the boiling point. Well, let me see, we got 100 degrees or 212. Now, for every 180 Fahrenheit units, there's 100 Celsius units. You might have seen like a 9 over 5 or 5 over 9. Remember back in your younger years for converting, or you can put like 1.8. So that's where that came from. For every 180 Fahrenheit units, there's 100 Celsius units. So that's why you'll see in the conversion 1.8. That's where that came from. Kelvin, talk about that shortly. Okay, on the next page, I'll highlight, circle, if you would. Highlight or circle those formulas. So highlight, circle these formulas. There they are. Degrees Fahrenheit, 1.8 times your degrees C, and then add 32. So remember, you multiply first, then you add 32. You guys remember that? Then degrees C, you take your Fahrenheit minus 32 and divide by 1.8. All right, can you do this one for me? Convert 99 degrees Fahrenheit into degrees Celsius. Oh, correct. How about this next one? Convert 41 degrees C, if you would, into degrees Fahrenheit. Well, that's going to be your top equation, if you believe, right? So it looks like it's going to be what? 1.8 times 41. Do that and then add 32. See, this stuff's pretty easy, isn't it? I hope. What'd you get? I got 105.8. 105.8? 105.8? There we go. Any problems with that one? Did you get it? Very good. Good job. Now, the Kelvin scale is the scientific scale. And you're thinking, well, why are you bothering with this? We'll never see it clinically. True, you won't. But we're going to see this when we do gas laws. The old Kelvin scale will be seen in gas laws. It's scientific, lowest possible temperature. Can't get any colder than this. It's called absolute zero. It's called 0 Kelvin, not okay, 0 Kelvin. They don't call it degrees Kelvin, they just call it Kelvin, which equals a negative 273. They tried to actually replicate that in a lab, but they couldn't do it. Now to convert to Kelvin, what you do is just add 273. So take your degrees C, add 273. That's all you do. That's all you do. All right, so what one would this one be? I got 37 degrees C. How many Kelvin would that be? Just add 273 to it. That's all. That's a pretty easy one. Just add 273 to it. What'd you guys get for that one?
310.
I got 310. 310? Very good. Good job. Going to the next page of your notes. So next page of your notes talks about energy. Energy, the ability to do work. 2 types of energy, potential and kinetic energy. You might have remembered this stuff like from basic physics class or sometimes chemistry and physics, you know, they kind of overlap sometimes. Stored energy, gasoline and water, food. Kinetic energy, energy in motion. So you take the gasoline, you burn it. Water over a dam, food energy, you learn chemistry. Write down all those hand cramping notes, huh? Yeah. but usually they give you handouts, so you don't have to write a lot of notes. Form of energy. Forms would be chemical energy. Remember ATP? What's ATP, class?
Energy.
True. Adenine triphosphate? That'll work. Yeah, there we go. Yep. Actually, it's called adenosine triphosphate, really, okay? And it's held in the terminal phosphate bonds. Remember that from metabolism? You guys want to go over metabolism?
Why not?
I don't want to go over metabolism. Radiant energy, light. Electrical energy, electricity. Mechanical energy, like my old 77 Buick. It's gone now, class.
Aw.
It blew a head gasket coming back from UMass. Actually made it home, the poor thing. Had the flashers on going 25 miles an hour. That's as fast as I could go. So normally what, hour and 15, took 3 hours. But I made it, the poor thing. So that'd be an automobile. Thermal energy would be heat. And as you guys know, take one form of energy, convert it into another. For instance, you can take the chemical bonds in ATP and turn them into mechanical energy with muscle contraction, for instance. Burning wood, you get thermal energy and radiant energy, so you get heat and light. Now, how do you measure this energy on the next page? So to measure this energy is measured with calories or joules. So a calorie, and a calorie, what that is, the amount of heat needed to raise temperature of 1 gram of water by 1 degree C. So 1 gram of water is going to be 1 ml of water. So I got this small little amount of water, and I want to raise the temperature a whole whopping 1 degree C. And it's called a calorie. Calories, heat energy. And then 1 kcal. Food energy is calculated in kcals. And you guys got to take nutrition someday? Well, if you're getting into nursing, yeah, you will. So 1 kcal is 1,000 calories. Or here's where it gets confusing. Don't shoot the messenger. I didn't make this crap up. But yeah, 1 calorie with a capital C is actually means a kilocalorie. So when you look at a candy bar wrapper and it says calories on it, it's actually kilocalories. So food energy is always going to be in kcals. Or for some reason, I don't know, just say calories with a capital C, which equals 1,000 calories with a small c. Just remember food energies and what? Kcals. All right, be in kilocalories. Now, specific heat. The ability of a certain material to absorb heat. It's also number of calories, heat energy, to raise the temperature of something, usually 1 gram of it by 1 degree C. Now, the units of measurement for specific heat, the ability of a certain material to absorb heat, is going to be calories per gram degrees C. Now, look at your instructor, forgot his leading zero. Who feels totally ripped off? Just 2 of you? Okay, save me for points off. Now, here's what we're going to do. Here's what we're going to do. Come on, my tired students. What's the matter? I don't feel a good learning connection today. What's the matter? You guys tired? Sick of learning? Why don't you skip the rest of the semester and we'll just go to cafeteria and have donuts all morning?
As long as we all
Isn't
get
that? Yes, I'll give all of you guys A's.
We don't want the diabetes.
Yeah, you'll get the made this. Yeah. Now, here's what we're gonna do. Come on, my tired students. I'll even let you out early today if you want. All right? Maybe it's like 10:35. What we have is we have 3 substances. We got some tin, some wood, and some water. So tin, wood, water. Now, what I'm gonna do, I'm gonna take these 3. Don't memorize these. What's called specific heats. So what I'm going to do is I'm going to heat them all up, put them on a table, and I'll heat them all up to 70 degrees C. So they're nice and hot. So they're each going to be heated up. Get them nice and hot. So heat them all up. Or let's say I heat them up to 180 degrees Fahrenheit. Get them nice and hot. So they're all hot. They're all same temp. So when you come up and you touch them, they're equally hot. All same temperature. Then what I'm going to do is I'm going to go ahead and I'm going to disappear for an hour. So we go out and say, come on, we'll get a coffee. And then we come back, and which one is still going to be the warmest? Remember, all same temp, all 180 degrees. They're all hot, equally hot.
And then you shut them off.
And then we stop heating them up, and then we go away, come back an hour later. What one is still going to hold the most heat? Yes?
10?
The tin.
Because it's metal.
Well, what's one, let's see, specific heat.